we'll be talking about end-to-end type safety today. So, however, let's start with a quick question round. How many of you use TypeScript on Prod? Raise your hand. Okay. A lot of more people should use it, but okay. Anyways, so what by type safety we mean is that on compile time, we can detect errors and we can operate in a type safe environment, right? And for example, if something changes on our server, we have client respond to that in a compile time environment and not in a runtime environment. So the big question right now is it even doable? So yeah, the spoiler alert, it is, and it is very sweet. It is yes with an asterisk because there is a caveat to this. So yeah, let me introduce myself. I am Siddhant, and you can pick me on at call me Siddhant. I am very active on Twitter. And so yeah, Siddhant usually translates to principles in English, and one of the very important principles, not the very important, but I think one of these, this is the list that I compiled for all the principles that you should use. And I think on somewhere in the last we have don't break stuff, and you should definitely don't break stuff on fraud. So yeah, there are a couple of techniques that you can use to prevent breaking your stuff, so prevent breaking your code at runtime. I would say that you should test your user behaviors. If you have a good set of tests, unit tests and integration tests that you have written, I think it gives a very solid indication that most of your stuff won't break. You should have multiple points of failure. There are a lot of techniques. I will not dive into how these techniques work, but you should have multiple points of failure in your code. And the third, I think, the very important that a lot of people miss with generally with web is we don't use static type checking, and this is where the TypeScript comes in. And I would like to hold that I'm not shouting in the next slide, but you should start using TypeScript majorly because I have used using in between asterisks or air quotes because a lot of the time when we write TypeScript, we are sort of fighting TypeScript with any's and giving it types with any's and objects. So I would highly recommend that you should start using TypeScript. You should define your types because it improves the DX very well, and so the developer experience is improved, and you have compile time, type checking, and you have compile time code quality ensured, right? So okay, now coming on to the end-to-end type safety. So we have a server, we have a client. We need to ensure type safety from our server to our client. And this is again, this is the user using your client, using your application which you have over-engineered. But again, we need to fill this sort of black box that how do we share type info from server to client. Right? We don't have a methodology to do that. So this is how the current standards work. I hope everyone can see that. If not, I'll share the slides. But this is how it works. So we define an interface, we define types. You can do this with any of the languages. You can use Java, Kotlin, any of this. So you can define types in the backend. For example, I have defined something called name and age, and you define something like I request params and I response params. And this ensures your type safety on the front end. But this is not the best way to do it because, for example, if something changes on the backend on a critical API, what happens? This is you on call, by the way, because if something happens, you are trying to debug, you are trying to put out fires that you haven't created. Because something changed in the backend API or something, a type was created. So you are on call and you are trying to figure out on the front end that what has happened. So, okay, what are the techniques that we can use to ensure type safety from a server to our client? So, one technique that comes to mind is something called code generation. So, this is a link that I provided. So, this is an open API code gen. This works with Golang. If you have Golang APIs, you should definitely use this. This is a different methodology because every time you change your API, this script runs and it generates methods that you can call on the front end, and this ensures type safety between from your request from your server to your client. So again, the huge caveat is you have to run this script every time a new API is added, and this you can run on GitHub Action. You can do a couple of things, but we can take it a step further. We can do better. So I want to introduce TRPC. So TRPC stands for TypeScript Remote Procedure Call, and certainly there is no RPC, there is no remote procedure call involved here. This is all happening on the types, and so yeah. Okay, this is a slide that I wanted to share. I have linked this demo, and you can look at it. I'll pause 30 seconds. You can have a look at this demo. And what is happening is, so we have a server. This is again, all of this is in a monorepo environment because TRPC works in a monorepo environment. So okay, we have something on our backend that we are changing, and our front end responds to it. So this is the power of type safety with TypeScript and TRPC. If you look at line number 21 on server.ts, that is where the entire magic is happening. We are sharing the entire state, entire type of the app router, and the app router is creating a TRPC client from that, and you can use that. Again, I won't dive into how, this is not a tutorial on how to use TRPC. This is just an introduction. So you can go ahead and work on that. Alright. Let's see a demo. Again, I'm very nervous in this demo. I will go to it. So yeah, on line number 5, as you can see, I again not going deep into the APIs. There is one file that is the server.ts, and there is one file called index.ts, and I am making an API call from line number 5. So I'm using use query. So TRPC under the hood uses something called React query. If you are user, it is very famous actually. So you can make calls directly from here. So okay. Uh, Okay, let me try. I'm not sure. So let me try making a new API call. So you can see the use query has all the values, all the types that are defined here. And here I have defined a method called greeting, which takes an input. And this Z is something called Zod. And if you have written APIs, you might have used something like Yup or Joy for validations. Zod is inbuilt into TRPC. It has type integration and it is written for type safety. So you should definitely give it a try. And you can definitely use Yup and Joy here as well, but the integration is not that great. You might have to use adapters for it. So again, I am passing an input, a Zod object, which has a key of name and which is taking a string and which can be nullish, right? So for example, if I remove this nullish and save this, and if I VS Code is breaking a little bit, and if I don't pass name here, my client breaks. Because what TypeScript now is saying is that we need an input with the name string. If you read the error correctly, it is saying that we need a name of string, right? So let me undo that, and I have made another. So let me show the magic of types, how types work. And VS Code is really good with all these types, and the DevX is really great. So let me go ahead and on this greeting, go to rename symbol and say hello on this. And you can see in server.ts, the same hello is automatically changed because it is referring to the types, right? So this is the entire DevX that TRPC gives. Again, not a very deep dive into TRPC. You can go ahead and look at the API. TRPC doesn't have only use queries; it has notations as well, just like how the React query would work. But again, the caveat is it works for mono only for now. And yeah, so this concludes everything. TRPC is works for only monorepos, and there are these are some links that I have used to prepare this. There is one another toolkit called Blitz.js that does something very similar, but the API is somewhat different. You can go ahead and read this as well. Yeah, that is it from my end. If you have any questions, let me know.